Hey there everyone. So in this video we're going to talk about ratios and proportions. Ratios are a comparison of two numbers. So comparison of two numbers by division. All right, so an example, there are three different ways to really commonly represent a ratio. We could write A to B, so that's comparing A to B. We could write A colon B, or A over B. And this right here, this fraction representation, really tackles this idea that it is a comparison by division. Okay? So, in example 1, let's write a ratio for the following situation. So, a person makes 6 long-distance phone calls and 15 local calls in 1 month. This first question is saying find the ratio of long distance to local calls. So they made 6 long distance calls compared to the 15 local calls. All right, this is long distance. This is local. All right, now I need to simplify this fraction. So what goes into both 6 and 15? What can I divide out? Well, I can divide a 3 from each of these, and that's going to be 2 over 5. Okay, so for every 2 long distance calls that they made 5 local calls. All right, next one, find the ratio of long distance calls to all of the calls that were made. So this doesn't tell us how many calls were made, but it does say they made 6 long distance and 15 local calls. So if I add those together, I'll get that they made 21 total calls. So long distance compared to the 21 total calls. So 6 is long distance, 21 is total. All right, now to simplify this, again, I can divide a 3 out of each of these. That's going to give me 2 over 7. That's going to work. So they made 2 long distance calls for every 7 total calls that they made. Okay? So 2 over 7, that's how it simplifies. Now, ratios. We use these a lot when we're talking about proportions. All right, so a proportion is an equation stating that 2 ratios are equal. All right, so for example, what forms a proportion with 12 over 15? Will give me an equivalent fraction to 12 over 15. Well, if I simplified that fraction, I would get, I can divide a 3 out of each of those. I get 4/5. Okay? 4/5 is equal to 12 over 15. Those two ratios are equal to each other. Another type of ratio, what if I took 4/5 and I multiplied each of them by 5? I would get 20 over 25. All of these are equal to each other. They represent the same ratio, just some are in simpler forms. Okay? Now, to solve a proportion, what we're going to do, maybe you've heard of it before, is we are going to cross multiply. Okay, now this is not cross cancel. Okay, cross cancel was when we multiplied fractions. To solve a proportion, when we have an equal sign here, we're going to cross multiply. So what does that mean? What does that look like? So I'm going to zoom in here. So to cross multiply, I'm going to take x times 5, and that's going to give me 5x. Now I'm going to drop the equal sign, and I'm going to multiply the other cross now. 10 times 3, which is 30. Notice how this started as an equation. X over 10 equals 3/5. When I cross multiply, it's going to make it all become one line. There isn't going to be that fractions anymore. Okay? Now from here, we know how to solve this step. We're going to divide both sides by 5. So I'll get x equals 6. Okay, so that's how we work through a problem where we need to cross multiply. What about in example 2? It gets a little bit more complicated. Cross multiply, so I'm taking 10 times all of 4v plus 7. I need to remember my parentheses there because we're taking 10 times that entire expression. Drop the equal sign. And then for the next cross, we're taking 15 times all of 6v plus 2. Now it's time to solve this. Distribute. So I get 40v plus 70 equals, distribute the 15, you get 90v plus 30. All right, now I got to get my v's on one side, my numbers on the other. Variables on one side, numbers on the other. So I'm going to subtract 90v from both sides. That's going to leave me with negative 50v plus 70 equals 30. Next step is to subtract 70 from both sides. So we'll get negative 50v equals negative 40. Then my last step, divide both sides by negative 50. That'll give me v by itself. And then negative 40 divided by negative 50. I could divide each of those by negative 10. And I'll get 4/5. Or if you left it as a decimal, it'd be 0.8. Okay? And I can go back and plug in for v and check both sides. And it better be the same answer. If I don't get the same answer, that's how I know I did something wrong. Okay, it's still an equation. You can still check your work. So that is how we cross multiply. We can also do it with equations. Or not with equations, with applications. All right? So in this first one, at a book sale, 6 books cost $13.50. That's a comparison. That's a ratio that we know. This is a ratio we know. 6 books, $13.50. All right, so when we set this up, books are on top, money is on the bottom. The cost is on the bottom. All right, so at that rate, how many books could you buy for 35 bucks? So we don't know how many books we could buy. All right, so books goes on top, money goes on the bottom. And we're saying at that rate, so these are equal to each other. Okay, there's a ratio that we know, and then that establishes how we're going to set up our unknown ratio. Books on top, money on the bottom. Now, all I need to do is cross multiply. So I take 6 times 35, that's going to give me 210, equals 13.5 times x. Now, to finish it out, I just need to divide both sides by 13.50. And that's going to give me x equals 15.5 repeating. So because it's an application problem, I have to make sure my answer makes sense in the context of the problem. You can't buy 0.5 repeating of a book. All right? And you won't have enough money to buy that 16th book. So you have to round this down. You can buy 15 books. All right? Because if I check that, I won't have enough money to buy the 16th book. I'm limited because I only have $35. Okay? So you can buy 15 books. Another type of application problem with ratios and proportions involves doing a scale. So an architect creates a scale model of a school. You can't build an actual school right away. First off, you got to have like a blueprint, a scale for it. All right. So the actual school is 50 feet high. The scale of the model to the actual school is 1 foot to 75 feet. Here's a ratio we know. 1 foot to 75 feet. Okay, I'm going to cancel off my units because that can make it a little confusing. This 1 represents the model. This 75 represents the actual school. Okay, we know the actual school is 50 feet high. So that's going to go on the bottom because that's the row that deals with the actual school. Estimate the height of the model. We don't know the height of the model. So that's going to be our x. Now we cross multiply. We get 75x equals 50. Divide both sides by 75. And we'll get x equals around, so I'm going to use my approximately. I'm not going to use my equal signs. I'm going to use my approximately signs, little squiggly marks. All right, 0.67, feet. So the height of the model will be about 0.67 feet tall. All right, so there is how we can do some application problems by setting up a proportion. Start with the ratio you know, and then fill out the ratio you don't know. Make sure you're paying close attention on what is represented in the numerator of your ratio and what's represented in the denominator of your ratio. All right, I've got, I believe, 5 you try now problems here for you. Just some extra practice. Make sure you start looking at that and do your practice problems for your homework as well. Let me know if you have any questions. I hope you're all doing well.